Okay, linear combination means it is with addition, normal addition process. Okay, you have to find 5 by using the numbers 2 and 1. How can I get 5? Linear combination means it should be of this form. This is called as the linear combination. Okay, so make use of 2 and 1 to rewrite here 5. So how can you rewrite 5 equal to 2 into 2 plus 1 into 1. Can you write down now? Yes, using 2 and 1, that should be in scalar multiplication. Okay, can you write 5 like this or no? Any other possibilities using 2 and 1? Yes? What are the other numbers which is possible for 5?
2 into 1 plus into 3.
2 and 3. 2 and 3. How can I write that 2 and 3?
2 into 1.
2 into 1 plus 3 into 1. What is the next possible alpha and beta? 4 and 1. So you can write as 4 into 1 plus 1 into 1. Can you understand what is the combination? You are going to have only one variable. You are going to rewrite that in terms of another variable which is going to be in the set where alpha beta is going to be some constants. Okay, it may be a constant or it may be a variable which belongs to the original set because we are in algebra. Okay. Our f can be any field. It can be a real number, it can be r square, it can be r cube, or it can be a matrices form, or it may be a polynomial, any field. According to that one, you are going to decide what is x, y, what is going to be your alpha, beta. Okay. Can you tell me how do you write 12 in as a linear combination of 4 and 3? is an expression constructed from a set of terms by multiplying each term from a set of terms TRMS by multiplying each term by a constant and adding the result. Here you go. Next one. So this is a general form of ordered linear combination. Whenever you are asked to define linear combination, write the definition which I am going to give you now. Okay, the first one is only a general description. When you are asked to write the definition which I am going to give you now. Okay, so take down. Let V be a vector space. Let V be a vector space over F and V1, V2, etc. Vn belongs to V. V1, V2, etc. Vn belongs to V. Full stop. Any vector in V, any vector in V of the form A1 V1 plus A2 V2 plus etc. AN Bn where A1 A2 etc. AN where A1 A2 etc. AN belongs to F is called a linear combination of the vectors V1 V2 etc. Vn. So this is the actual definition for a vector space. Okay, straight away we are going to go into the problems. It's easy only. Try to understand how to assume the elements and how to solve it. Okay, so take the first problem. Everyone ready now? Anyone still writing? First one. In R cube, determine whether 1 7 minus 4 vector 1 7 minus 4 is expressed as a linear combination of u equal to 1 minus 3 2, v equal to 2 minus 1 1 in R3 or R3. So what you are supposed to check? You are given a vector, but identify this vector can be written as a linear combination of these two vectors. Anyone wants to go out now? Most of you are watching outside. No issues with the permission. You can be outside till 12:15. Anyone? Yes? Shall I continue? So what you are supposed to do now? You have to check whether the given vector can be written as a linear combination of u and v. What is the meaning of linear combination? That term should be written as a multiplication of the vector in terms of addition. Both the vectors should be added and both the vectors should be multiplied by some constants. Do you know what are the constants, ma? Okay, well, we are able to identify directly what is the constant. Constant is there or no? Check பண்ணி பார்த்தா we don't know directly what is going to be that constants. So for that we are going to assume it randomly to be like a1, a2 or alpha 1, alpha 2. We are going to solve it and we are going to find whether those values are possible or not. If we are able to find any constants like that, then it is written as a linear combination. If we are not able to find any constants, means what will be the conclusion? It cannot be written as a linear combination of the given numbers. Okay, the constants நம்ம assume பண்ண போறோம், solve பண்ண போறோம். And the constants என்ன நம்மளால கண்டுபிடிக்க முடியுதுன்னா, yes, it can be written as a linear combination. If you are not able to find the constants, it is not a linear combination of the given numbers. Is it clear how to solve the problem? So start with the solution. Let the Rpla 1 7 minus 4 is equal to alpha 1 u plus alpha 2 v. Alpha 1 u plus alpha 2 v. U and v are given in the statement. Right? That is 1 7 minus 4 is equal to alpha 1 into 1 minus 3 2 plus alpha 2 into 2 minus 1 1. So what you will get in your right hand side, ma? Just vector addition. So what you will get? If you multiply alpha 1, what you will get? Alpha 1 minus 3 alpha 2, 2 alpha 1. If you multiply by alpha 2, what you will get? 2 alpha 2 minus alpha 2 alpha 2. Just normal multiplication. How will you add two vectors? Vector addition, ma? Corresponding element should be added. So what will be your final answer? What will be the first element? Alpha 1 plus 2 alpha 2. Combination of the first elements. What will be the second element? Alpha 1. 3 alpha 1 minus alpha 2. Multiply the corresponding second element. So add the corresponding second element. Now the third element, 2 alpha 1 plus alpha. Okay, normal addition and multiplication only we are doing. Okay, so what you have said now, this LHS is equal to the RHS. Your object is to find alpha 1, alpha 2. How will you solve? LHS is equal to RHS, no? Then how will you solve and find what is alpha 1, alpha 2? The corresponding coefficient should be equal. So alpha 1 plus 2 alpha 2 should be equal to what? 1. The second one should be equal to 7 and the third one should be equal to minus 2. So you are having three equations to solve. So you can try to solve that one and you can find what will be our alpha 1 and alpha. Okay, so right? Equating the coefficients. Sorry, you should not write coefficients. Equating the corresponding components. Equating the corresponding components. Equating the corresponding components. We get. So equate both. First element is equal to the first element. So alpha 1 plus 2 alpha 2 equal to 1. Second one minus 3 alpha 1 minus alpha 2 equal to 7. Third element, both the right hand side and left hand side should be same. So 2 alpha 1 plus alpha 2 equal to minus 4. You can solve it and you can find what is the alpha 1 and alpha 2. Find it. Tell me what is alpha 1 and alpha 2. How can you solve, ma? Which two equations you can consider? 1 and 3. Or 2 and 3 will be easy. If you add 2 and 3, what you will get? Alpha 2 obviously get cancelled out. So minus 3 alpha 1 plus 2 alpha 1 will be minus alpha 1. Just add 2 and 3 an equation. 2 plus 3. So you get it to be minus alpha 1 in the left hand side. Right hand side what is 7 minus 4? 3. So what is alpha 1? Minus 3. Substitute any one of the equation and find what is alpha 2.
2.
Alpha 2, yes. Sorry, what is alpha 2? 2. Everyone getting same answer or different answers? Alpha 2 is equal to 2. So we were able to find the unknowns now. So what is the conclusion you can say? Hence the given vector can be written as a linear combination of u and v. Well, in the constants நம்ம கண்டுபிடிக்க முடியாம ஒரு situation வரலாம். அப்படி வந்ததுனா what you have to read the conclusion? It is not a linear combination of the given vectors. Understood? Easy or not? Easy or not? No? Yes? Just you have to assume it correctly. That's all. Okay? Here you go. So right? Therefore 1 7 minus 4 is equal to minus 3 into 1 minus 3 2 plus alpha 2 is 2 into 2 minus 1 1. So right, hence the vector 1 7 minus 4 can be written as a linear combination of u and v. So can you verify whether your alpha 1 and alpha 2 are right now? How will you verify? You are written here. From this, how can you check? If you simplify the RHS, you should get your LHS. So if you multiply minus 3 inside, what will happen? Minus 3. This will become 2 into 2 will become 4. So what is 4 minus 3? Next one. Express the polynomial b is equal to t square plus 4t minus 3. b equal to t square plus 4t minus 3 over r as a linear combination of the polynomial e1 equal to t square minus 2t plus 5, e2 equal to 2t square minus 3t, e3 equal to t plus 3. Okay, so here what is our vector field? It is going to be a polynomial. Okay, vector space is going to be a polynomial. What is your field, no? Field is R over R. What is R? Set of all real numbers. Okay, here our vector space is going to be a polynomial and the field is going to be the real line R. Now we have to check whether this can be written as a linear combination of E1, E2, E3, the same procedure. Since it is in R only, we are going to assume it to be alpha 1, alpha 2 and alpha 2. Okay, so start the solution. Let V is square minus 3 plus alpha 3 into E3 is 3 plus 2. So in the previous problem we have equated the components on both sides. Both is of triple order vector. Here how will you compare now? It is a polynomial. So how will you compare with left hand side and right hand side? The corresponding coefficients. Because it is an equation of degree 2. You can equate the corresponding coefficients on both sides. For that, first you rewrite the right hand side in terms of the degree order. Collect all the t square terms, t terms and the constants. Okay, rewrite your RHS. So what are the t square terms now? Shall I write it directly? If you multiply alpha 1 inside, what you will get? Alpha. If you multiply alpha 2 plus 2 alpha 2. Multiplying alpha 3. Any t square terms are there? Any t square terms are there? No. T square contains only 2 terms. So into t square. Plus. Now collect all the t terms. Do it into 2 more steps. Multiply alpha 1 inside, what you will get? Alpha 1 t square minus 2 alpha 1 t plus 5 alpha 1. Multiplying alpha 2. 2 alpha 2 t square minus 3 alpha 2 t plus alpha 3 t plus 3 alpha 2. Just ordinary multiplication. So now we club all the corresponding coefficients. Collect all the t square terms. Alpha 1 plus 2 alpha 2 t square. Next, collect all the t terms. Minus 2 alpha 1 minus 3 alpha 2 plus alpha 3 into 2 plus the last one will be all the constants. So constants are 5 alpha 1 plus 3 alpha 3. Writing it in terms of a polynomial. So when LHS will be equal to RHS? Only if the corresponding coefficients are same. So we are going to equate both the coefficients. We are going to solve it and find what is alpha 1, alpha 2 and alpha 2. Okay, so right. Equating the coefficient on both sides. Equating the coefficient on both sides. We get equating the coefficients on both sides. We get. So compare coefficient of t square. Left hand side, what is the coefficient of 1? So 1 equal to. Right hand side, what is the coefficient? Alpha 1 plus 2 alpha 2. Next, compare the coefficient of t. Left hand side, what is the coefficient? 4. Right hand side, minus 2 alpha 1 minus 3 alpha 2 plus alpha 2. Finally, you equate the constants. What is the left hand side constant? What is the left hand side constant? Minus 3. Be careful with the signs. Right hand side, what are the constants? 5 alpha 1 plus 3 alpha 2. So you are getting 3 equations and 3 unknowns. So you must try to solve it and define what is alpha 1, alpha 2, alpha 3. Find it. Find what is alpha 1, alpha 2, alpha 3. What are the methods you can solve now? Simultaneous equation. Or do you know about a non-homogeneous equation? Previous topic. This is a non-homogeneous equation. Yes or no? If you are thorough with the matrix concept, you can convert this up to form Ax equal to B. Then you can consider the augmented A matrix A comma B. Reduce it to a upper triangle matrix. Then by back substitution you can find the unknowns. It's your choice. Okay, solve பண்ணி கண்டுபிடிக்க இதான் procedure எதுமே கிடையாது. Whichever is convenient for you, you solve by that method and find what is alpha 1, alpha 2 and alpha 3. me what is alpha 1, alpha 2, alpha 3? Not to proceed with simultaneous also you can do. We don't know matrix helping solve a simultaneous equation. The equations they are solved by simultaneously. Anyone got the answer? Then let's check your answer now. Check your answer. Alpha 1 is -3. Alpha 2 2. Alpha 3 is 4. Alpha 3 is 4. So we are able to find the unknowns. So hence it is possible for us to write the given vectors in terms of the given polynomial. Okay, so write a conclusion. Therefore t square plus 4t minus 3 is equal to so what is alpha 1? Minus 3 into the e1 plus alpha 2 is 2 into e2 plus alpha 3 is 4. Even if you don't write the polynomial, write a simple equation as minus 3e1 plus 2e2 plus 4e3. For conclusion, v equal to, write like this. Just substitute and alpha 1, alpha 2, alpha 3 and rewrite. No need to substitute v and e also. So whether we were able to write as a linear combination? Yes or no? Yes. Hence it is possible for us to write V as a linear combination of E1, E2 and E3. Any doubt now? Okay. Next one. Write the matrix. E equal to, capital E is equal to, capital E is equal to the 2 by 2 matrix. Capital E equal to the 2 by 2 matrix 3 1 1 minus 1 3 1 1 minus 1 as a linear combination of the matrix A equal to 1 1 1 0, B equal to 0 0 1 1, C equal to 0 2 0 minus 1. So now this is the third possible case where the elements are in the matrix form. Same similar procedure now. We have to identify whether E can be written as a linear combination of A, B, C. So what are the constants you will assume? Alpha 1, alpha 2 and alpha 3. So here you are going to solve it based on your matrix concept and you are going to find what is alpha 1, alpha 2 and alpha 3. So start the solution. Let E equal to alpha 1A plus alpha 2B plus alpha 3C. Okay, substitute your E, A, B and C. So E is 3, 1, 1 minus 1. That should be equal to alpha 1 into B, 1, 1, 1, 0 plus alpha 2 into B, 0, 0, 1, 1 plus alpha 3 into C, 0, 2, 0, minus 1. Now it is matrix addition. Add and tell me what is the final result. Add all the three matrices. Alpha 1, alpha 3. What will be the first element? Alpha 1. How do you get it? Alpha 1. Add all the first row, first element. Alpha 1, alpha 2, alpha 3 should be multiplied inside. So what is the answer? Alpha 1 into 1 is alpha 1. Alpha 2 into 0 is 0. Alpha from that what we can say? Alpha 1 should be equal to 3. Directly we got the answer. Next we'll be having three equations. We can substitute and you can find what is alpha 2 and alpha 3. So that equating both sides, we get. So compare the first row, first elements. Left hand side it is 3, right hand side it is alpha 1. So that you get alpha 1. Now first row, second element is 1. Right hand side, the first row, second element is alpha 1, 2 alpha 2. Already know what is alpha 1. Alpha 1 is 3. So if you substitute alpha 1 as 3, bring it to the left hand side, it will become negative. What is 1 minus 3? Minus 2. So 2 alpha 3 is minus 2. So what is alpha 3? Minus 4. You got alpha 3. Now second row, first element, alpha 1 plus alpha 2 should be equal to 1. So again alpha 1 is 3. Tell me what is alpha 2? Minus 2. Okay, got the answer easy. What is the next step we should do? Substitute and rewrite the first equation. So right, hence E is equal to 3A minus 2B plus minus C. E is equal to 3A minus 2B minus C. If you want to cross verify means, the right hand side you substitute A, B, C. You have to simplify and you have to check whether you are getting that E matrix or not. Okay, if you follow the procedure correctly, surely you will get the E matrix. Okay, easy or difficult now? Easy or not? One more problem. One more. Express. Before that, everyone has completed this one, or anyone still writing? Anyone needs time to write? Finished? So right, express the vector v equal to 2 minus 5 3 in R cube as a linear combination of E1 equal to 1 minus 3 2, E2 equal to 2 minus 4 minus 1, E3 equal to 1 minus 5 7. 1 minus 5 7. Now you are getting used to this one. What is the step on your right? V is equal to alpha 1 E1 plus alpha 2 E2 plus alpha 3 E3. So right, let V equal to alpha 1 E1 plus alpha 2 E2 plus alpha 3 E3. Now substitute your vectors. 2 minus 5 3 is equal to alpha 1 into E1 1 minus 3 2, alpha 2 into E2 2 minus 4 minus 1, alpha 3 into 1 minus 5 and 7. Tell me how we relate the right hand side now? It should be also a triple order term. What is the first one? Compare all the first elements. So what you will get? Alpha 1 plus 2 alpha 2 plus alpha 3. Combining all the first elements. Combine all the second elements. Minus 3 alpha 1 minus 4 alpha 2 minus 5 alpha. Compare all the third elements. 2 alpha 1 minus alpha 2 plus 7 alpha 2. Just combining the corresponding components. Tell me what is the next step? Compare the components on both the sides. Here you don't write as coefficients, no? Coefficients will come only for the polynomial. So comparing the components on both sides. So what is the first equation? Alpha 1 plus 2 alpha 2 plus alpha 3 equal to 2. Second one, minus 3 alpha 1 minus 4 alpha 2 minus 5 alpha 3 equal to minus 1. 2 alpha 1 minus alpha 2 plus 7 alpha 3 equal to 3. So what should be your objective now? 3 equations, 3 unknowns. By any one of the method you must solve and you must try to find what is alpha 1, alpha 2 and alpha 3. Okay, normally it will be a non-zero integer. Okay, so remaining part I am giving you the work for today. Only that solving part I am giving you. I want everyone to complete it and bring the answers of alpha 1, alpha 2, alpha 3 in your next class. Is that clear? Or I will ask any excuses for that also. Next class is tomorrow is Friday, whichever. Friday, whichever. First one. Okay. What? You go home and solve. So listen, ma. The next topic what we are going to discuss is called as the linear span. Okay, we discussed what is the linear combination. The next one is called as the linear span. Linear span means what is the meaning is that it will be having the set of all possible combinations. Okay, so when it will be called as a linear span, it will be having the set of all possible linear combinations. Here what we did in linear combination, in a vector space, we are given only one element. And I asked to represent it in terms of 3 other unique elements. Okay, but that is not so right. The same vector can be written as a linear combination of some other vectors also. Yes or no? Here I have given D1 equal equal. Okay, it can be written as a linear combination of some other equal if I insist also. That is also possible. Okay, so if you are able to find all the different possible combinations, that is called as the linear span. Okay, here in the problem what we will be discussing is that whether it is going to be a linear span or not. Okay, like a similar one, not exact. Any difference is going on. Here you have given one particular value to write in terms of some other vectors. That it will not be given. You have to assume it as a generalized one. So linear span means what is the meaning? Set of all possible combinations. I mean, one particular value which we have put on our we have to assume the vector as a generalized one. Okay. For example, second order terms we can assume it to be xy. Okay, and we have to prove that this xy can be written as a linear combination of the vectors. Whatever may be the xy values. Okay, if it is going to be a triplet, xy is it. If it is going to be a 2 by 2 matrix, yes, A11, A12. நம்ம ஜெனரலா அஸ்யூம் பண்ணி அது வந்து ஒரு லீனியர் காம்பினேஷன் நம்ம எழுத முடியும்னு நம்ம சொல்றோம். Okay, because what is the meaning of linear span? Set of all possible combinations. இங்க நம்ம டிஸ்கஸ் பண்ணது only one possible combination. Okay, span நம்ம டிஸ்கஸ் பண்ண போறது set of all possible combinations. Similar approach, but we are going to assume it as a generalized one and we are going to give the proof. Okay, next topic, linear span. Linear span. Linear span. SPAN. Linear span. SPAN. Take the definition. Let V be a vector space. Let V be a vector space over F. Let V be a vector space over F and the set of all, then the set of all linear combination, set of all linear combination of the finite subset of S is called the linear span of S is called the linear span of S and is denoted by L of S. L of S. Right notation. So what is the meaning of this notation? Linear span of S. Okay, so write next line. That is L of S is equal to the set of all possible terms alpha 1 v1, alpha 2 v2, etc. alpha n vn such that alpha I belongs to R, vi belongs to S. Vi belongs to S. Vi belongs to S. So make a note. Always L of S is contained or equal to V. The symbol is contained or equal. Second one, if S is equal to 5. What is 5 now? Empty set. If S is equal to 5, what will be L of S? L of S will be 0 because no elements are down. So if S is an empty set, then L of S will be 0. So only we consider all S to be a non-empty set. At least one element should be there. Okay. Remember this first point, the problems will be taken in form first point. Okay. How we are going to solve the problems is that if we call as a linear space for linear span, if you are able to prove that L of S is equal to V. Namnale we prove panna mudinjirna, then we can say that it is going to be a linear span. What is the first condition we are having? L of S is contained or equal to V. If you are able to prove that, it is the obvious condition. Probably direct assume panikalam. Okay, what is the next one you are supposed to prove is that you have to prove that V is contained or equal to L of S. Okay, enna prove pannom? V is contained or equal to L of S. If these both conditions are satisfied, what you can say? L of S வந்து V குள்ள இருக்குன்னு எதிர்பார்க்கிறோம். இதுக்கு என்ன அர்த்தம்? V வந்து L of S குள்ள இருக்கு. Apna எப்போ possible? Only if both are equal. Amma yes? You set to solve. You accept as A and B. A வந்து B குள்ள இருக்குன்னு சொல்ற. Okay? திருப்பி என்ன சொல்ற? B வந்து A குள்ள இருக்குன்னு சொல்ற. அப்பனா எப்போ நடக்கலாம்? Only if A and B are equal. Can you understand or not ma? When taken ஞாபகா என்ன சொல்றீங்க? A வந்து B குள்ள இருக்கு. ஓகே, இன்னொன்னு என்ன சொல்ற? B குள்ள A குள்ள B இருக்கு. இது எப்ப நடக்கும்? A வும் B யும் ஒண்ணா இருந்தா மட்டும். அந்த லாஜிக்ல நம்ம ப்ராப்ளம்ஸ் சால்வ் பண்ணணும். There is a rare condition. So in all the problems we assume this condition directly. So what is the target now? We have to prove that V is contained in or equal to L of S. If we are able to prove that one, then directly we can say that V will be a linear span of the given subset. That's stop after this one. We continue this.